Here we're going to talk briefly about some problem-solving strategies and then go through examples of a couple different strategies. First of all, it's important that we think about these steps as we are approaching word problems. Okay, first thing is that we really need to read. Usually that means reading more than once. The first time I read through a problem, I am looking to see what the question part is. What is the problem asking me to do? And then after I have determined what that is, then I go through and start looking at what information am I given and start thinking about how to get from what I am given to what I need. Okay, so it is not unrealistic that you should need to read a problem at least 3 or 4 times. Second, we need to devise a plan. We've got a lot of different lists on this problem-solving strategies chart here, and we are going to go through a couple of those. Making a table or a chart, if we have like a list of things, that might be a good idea. Looking for a pattern, we've done some number patterns. So this is also one where we should be familiar with. Solving a similar or simpler problem means, can we condense the problem that we have into something that is more basic? Like maybe it's something geometric and we can really just take the whole figure and then redraw it as maybe a triangle, and then we're looking at that triangle, maybe area of a triangle, and to figure out how that applies to the original problem, the broader problem. Drawing a sketch is a great idea, especially when we have anything geometric happening. Inductive reasoning, again, is similar to looking for a pattern, so these two are related. We can write an equation and solve it. This is actually tied, I would say, a little bit to solving a similar or simpler problem, because we're taking it from full sentences and trying to write it into a condensed statement that we can then translate into math. Okay, and we are going to do an example of some of that as well. If a formula applies, we can use that. Sometimes a formula will be given, sometimes it's one we need to know. Also, working backward. If it's something where some steps happen successively and we know some ending information and we need the original information, we can work backward. We're going to look at an example of that one as well. Guessing and checking is never a bad option. Sometimes it's not the most efficient, though, so I would use this. Sorry, there was an announcement. So guessing and checking is another option, but maybe I wouldn't use that too judiciously. Trial and error is very similar to guessing and checking. Using common sense, I don't know how helpful that is as a list, or in a list of strategies, but it is an option. And then look for a catch if an answer seems too obvious or impossible. Really, we need to make sure, after we get an answer, we need to make sure that it matches the question that we are looking for. And there's a good chance that if we arrived at an answer very quickly, maybe there's some information that we are missing. So that's more of not a means of getting to an answer, but a means of checking to see whether or not our answer is reasonable. Okay? All right, so, and then after we have devised our plan, then we will carry out that plan, or maybe a combination of a couple of these plans. And then, like I said, we need to check our answer and make sure that it is reasonable. So we're going to do 2 examples. The first example here gives us 3 alarms. Okay, we have 3 alarms. One rings every 30 minutes, one rings every 20 minutes, and one rings every 45 minutes. Other than being crazy annoying, our question is, if they ring it simultaneously at, that should be a T, sorry, at 12:34 p.m., when is the next time that they will all go off at the same time? So for this one, my suggestion would be to start with a table. So we're going to make a table of when each of the 3 alarms ring, and then hopefully my table won't be too terribly big, and I'll run into a time when they overlap. So I'm going to do this by labeling my alarms. Okay, so I want to know, when will they go off? So our answer is going to be sometime. When will they go off? And the first one, I'm going to call that A. The second one that rings every 20 minutes is going to be B. And the last one every 45 minutes, I'm going to call that alarm C. And then I'm going to make a table this way. A, B, C. Okay. And I will be filling in how often each of them rings. Okay, and we know that they all start at 12:34 3:34. Okay, now a couple options for filling out my chart. One thing that I could do is I could take alarm A and I could write the next 20 times that it rings, okay? Hopefully my table doesn't need to be that big, but as it is, I don't quite know how far to go. So I'm going to fill in maybe 5 or 6, and then I'll start filling in B and then C and see if I get to an overlap. If I don't, then I know that I can keep adding sometimes. But for now, I'm just going to do a few and then kind of fill all of them out together instead of just 20 entries for one of the rows. Okay, so the first alarm is ringing every 30 minutes or every half hour. So if it's at 12:34, the next times that it will ring will be at 1:04 and then 1:34 and then 2:04, 2:34, and 3:04, and I'm going to stop here. I might need to go further later, but I'm going to stop here for now and hop to alarm B. So alarm B is ringing every 20 minutes, okay? So filling in some times for this. It's ringing the most often of all of them, so I'll probably have to have the longest row here. Okay, so 12:34, the next time is going to be 12:54, and then 1:14, and then 1:34, and I do see right here, actually, let me go ahead and finish this, that alarm A and B are both ringing at 1:34, okay? So instead of continuing with alarm B, I'm going to hop to C, and if alarm C also rings at 1:34, then I know that's my answer. If it doesn't, I can go back up to the second row and continue filling out more times. So alarm C rings every 45 minutes, okay? So it rings at 12:34, and then the next time it will ring is going to be at 1:19, and then at 2:04, and at this point I've already passed 1:34 p.m., so I know I need to keep going. While I'm here, I can go ahead and fill in a couple more times. There's really no specific formula for the order that you need to fill these out, okay? So 2:49 is going to be the next time, and then 3:34, and I'm going to stop there. Again, might need to fill in more in a minute, okay? Then back up to alarm B, 1:54. This is the 20-minute alarm, so then I'm going to have the next alarm at 2:14, and I need to continue this. Okay, and then at 2:34, and there's another overlap time with alarm A, but not with alarm C, okay? So then 2:54, 3:14, which is a little further than I went before, but I am not quite there with alarm C, but I see now that I have another overlap with the 3:34 for alarm B and C. Okay, so alarm B and C are both going off at 3:34 p.m. Let's hop back to alarm A and see if it also goes off at 3:34. The last time I have written down is 3:04, and remember this is the 30-minute alarm, so yes, in fact, this one does ring at 3:34. So my final answer to this one is 3:34 p.m. Okay, so in this case, my approach was to make a chart to figure out where they would overlap, and that's probably one of the best ways here. It's probably better than guessing and checking, because in the process of guessing and checking, I would have to be writing down a lot of the in-between times anyway. Okay. All right. For this next one, we have Bob gave 4/5 of his pencils to Barbara, then he gave 2/3 of the remaining pencils to Bonnie. If he ended with 10 pencils left, how many did he start with? Okay, so here's our question part. How many did he start with? We know how many he ended with. Okay, we want to know how many did he start with. This is a problem that is best approached with working backwards. Okay, so I'm going to combine methods a little bit. I'm going to try and write what I have starting at the end and write those as sentences that can be translated into math and then I'll solve those math equations. Okay, so what I mean by this, I have that he ended with 10 pencils left. So he has 10. Okay, so he has 10. Okay, now let's see, has 10. And we also know that he gave 2/3 of his pencils away. That's the second gift, the one to Bonnie. He gave 2/3 of his pencils, which means that the 10 is 1/3 of the amount that he had after his gift to Barbara. Okay, so 10 is 1/3 of the amount, and we can say before giving 2/3 to Bonnie. Okay, or we could say after Barbara, either way. So now this statement, 10 is 1/3 of some unknown amount, we don't know what that is, that sentence I can translate directly into an algebraic statement. Okay, and I have some words that indicate certain operations. Okay, the word is indicates equals. Okay, 1/3 is a fraction. The word of indicates multiplication, and then the word, since I just have some unknown amount, this is what I will be solving for. That's my unknown. Okay, so I can write this as an equation like this. I can write 10 equals 1/3 of, and I'm going to use a variable here. I'm going to use, we'll use P for pencil. Okay, so 1/3 of P, or 1/3 times P. Okay, at this point, now I'm on the looking at the 6th of the methods in the problem-solving strategy chart. But now I have my equation, and I can solve this. So to solve this, I'm going to multiply both sides of the equation by 3. Okay, that cancels this out. That gives me a 30 over here. So I get that P equals 30. So 30 is not my final answer. It's the number of pencils that Bob had after his gift to Barbara, but before his gift to Bonnie. Okay, so I'm going to go backwards one more time and write another statement to figure out how many he had before giving some to Barbara. Okay, so to do this, we'll say it this way. Okay, so now he has 30, okay, and then that amount is, well, if he gave 4/5 away, then that means he was left with 1/5 of his original. Okay, so 30 is 1/5 of the original amount. Okay, or the original number. Okay, and again, once I have this simplified statement, it's a sentence that I can translate directly into math, and I can write 30 equals 1/5 times, and I'm going to use n for the original number. I try to avoid using o's for variables because then it looks like a 0. So 30 equals 1/5 times n. To solve this equation, I'm going to multiply both sides by 5 to cancel out that 1/5, and I end up with 150. So he originally has, and really I should put a label on here, he has 150 pencils to start with.